All right, so this is the two-step analysis of the sprint performance using the MySprint app and using our spreadsheet. So in this first step, you have to film a sprint from the side here, and you have to detect the starting picture. So you can use the zoom option of the iOS device you use. So it's an iPhone or an iPad. And the idea is that when you detect the first propulsive movement here, you see the back foot pushing, you click on the start here. Then your athlete goes towards the 5-meter mark, and when you see that the middle of the pelvis line is aligned with the pole, you can click on 1 to see the first split time. Then you go here frame by frame by clicking on this arrow here, and you have the same position for the 10-meter split. When the athlete is at 15 meters, you go back and you give the 15-meter click. Then exactly the same thing for the 20-meter. So you have to make sure that the setting of the poles is correct and follows the instructions. 20. Then you see the 25 meters, and you will tap on the screen here, 25, and the 30-meter here in a few seconds. So you have to go frame by frame to that pelvis position aligned with the middle of the pelvis and the pole. So that's 1 or 2 pictures before. So you have to be very accurate on that. There we go. And you click on the split. So the next step is you are going to enter the split times. So first, second, third, etc. into our spreadsheet. So this is what the spreadsheet looks like. So you just have to open the spreadsheet. Basically, this is how it looks like. So you will have at the end of the computations the entire graphs and the entire set of data. So first here you will type the stature, the age of the athlete, the body mass here, the temperature here, and the local air pressure. Then you will type in the split times that you have analyzed. So I am typing here exactly the same split times as the app gave me. So 2.579, etc., etc. So you can go with the 20, 25, and 30 meters. There we go. And then you will have to adjust these split times to an exponential model. And to do so, you will look for the solver, the Excel solver. It's an add-in macro that is installed in Excel. And the solver is pre-registered, so you set the value of the square differences, of the sum of the square differences to 0. You click solve, and the solver will fit the actual data with the exponential model. So the sum of the square differences between the split times in yellow here and the model in blue is almost perfect. So you have the force, velocity, and power traces. And remember, these computations are really, really close to force plate values. And then in this block of variables here, you have the main important variables for the FV profile analysis, including the max speed and including V0. So remember that, because it's the V0 that we are going to use in the next spreadsheet. There you go.